In this video, we will be talking about the illustration of the concave mirror. So we will be tackling all cases of concave mirror from case 1 to case 5. So let's start. We'll first start with the title, so concave mirror ray diagram. I know it's already written above at the title of this note, but it's better if we write it anyways. Rewrite it. So let's start for case 1. Before we even start though, I think I've made clear already about the importance of ray diagram in the recent video, which is all about plane mirror. I could give some additional informations and probably reiterate what I recently said. Ray diagram is useful for ophthalmology, but either way, it's also a vital lesson in physics, grade 10 physics, I suppose. If it's not in your school, if you don't learn this during your 10th grade in high school, I'm not sure. Every school differs. Some schools are advanced, some schools aren't really that advanced, some are relaxed. But yeah, as for my school, we studied this during 10th grade, first quarter physics. So yeah, without further ado, for case 1, it will be tackling the situation whereas the the starting point is located before the center of curvature. I might not explain this correctly, completely, but I hope you'll be able to watch videos that would be relevant about this lesson, because right now I'm just trying to show you how the ray diagram of concave mirror is illustrated from case 1 to 5. So yeah, we are given this kind of illustration. So we have the principal axis. So here, I'm so sorry. Here is the the real side, and here at the right is the virtual side. So in this case, this is just how we illustrate, how we I'm not sure how to explain this well, but this is where we end up. So I hope you're able to compare. These diagrams are the same, but the difference is that the 3/4 of the entire circle is removed. So we have this beautiful curve right here, and that would be our concave mirror. So this is how we draw a concave mirror. It's an inverted C. And just like the plane mirror, which is illustrated as this, we have these lines at the outer shell of the concave mirror. So let's disregard this now, because we now have, let's disregard this part, this diagram, and we'll be using this. Alright, so what I mean by the first point, this is our first point. So as you can see, this is before the center of the curvature. C stands for center of curvature, and the purple mark is the focal point, which is abbreviated as F. And this is our eye, of course, as usual. And yeah, this is our mirror, virtual, real side, principal axis here. Alright, before the center of curvature, this is how we draw it basically. So we need two colors. So in this case, I have mint green and velvet red. I'll be using mint green first. This will be our first color. So do that. First line horizontal until we meet this curve, this part of the curve, and so we intersect as the line reflects, we purposely intersect our focal point, and yeah, place an arrowhead there, and use the next color, the velvet red. We also use this to intersect the focal point, and until we meet this part, we reflect horizontally. So it should be a perfect horizontal line. There must be no curve. And we can see the projected image. So yeah, the point that I've been trying to say a while ago, this point, is the location of the real object. And right now, the location of the image, I have to elaborate this first. The object and the image, these two words aren't exactly the same in this lesson. Object can be the real image, and the image can be a virtual image. It's not real. And in this case, we have the projected image. So we basically have that. And let's draw our conclusions. The object, I'm sorry, this is singular. The object is, so provided that the real object is located at, before the center of the curvature, before, not at, before the center of the curvature, it could be concluded that object is real because the object is at the real side, not the virtual. So object is real, object is inverted. Why is it inverted? Because it's at the other side. So you can see that the arrow here, the initial location of the object is upright, in a position of upright, but in this case it's the opposite arrow, so we call that inverted position. And we can say that the object is diminished. Why is it diminished? Because obviously we could see that the height of the initial object is bigger compared to the final, the second location of the object. There's a difference, if you can see it clearly, hopefully. So yeah, in case that you haven't understood this yet, I hope you could understand the pattern because we still have 4 more cases to go. So this is only for case 1, before the center of curvature. Let's move to case 2. Case 2 this time is on the center of curvature. So basically in this illustration, we have our object before the center of curvature. This time, let's add the template. There you go. Let's make it accurate alongside the lines. There you go. Partial eraser. Remove this. This time, the location of our object will be exactly at, exactly at the center of curvature. So, let's use our mint green. Illustrate horizontal that way. Oops. Redo. Alright. Then, reflect. We will intersect the focal point as usual. That will always be a must in illustrating ray diagram concave mirror. So put an arrowhead there. And the next color, the velvet red. There you go. Intersect the focal point and reflect horizontal, perfect horizontal. There you go. Not all illustrations are perfect, but supposedly there will be an intersection. So there you go. It looks wrong. This is our intersection. So basically we can conclude that the object is real because it's still at the real side of the illustration. The object is the same size as the initial location of the object. So they're basically the same size, I suppose. My illustration is not really that accurate. Let me fix that. We'll make this focal point a little bigger, because on the center of curvature, supposedly, what we can see, the technique is that this part, we can see that this kind of illustration, it looks like a Ben 10 watch, the symbol of a Ben 10 watch. So with that in mind, we can already derive that, even without illustrating it, we already know that on the center of curvature, object is real, it's the same size, and let's fix this arrowhead. The object is actually, I forgot. Object is real, object is the same size, and the object is still inverted. There. Why is it inverted? Because it is below the principal axis. The arrow is following the inverted form compared to the upright form of the initial. So that's our case number 2. Forgot to place 2. Oops, wrong color. There you go. Alright, let's move on for our case 3. Case 3 is between the center of curvature and the focal point. Alright, let's add the template again. Alright, perfect. Let's remove the initial location, and we'll place it in between the C and our F, because that's basically what the case 3 is all about. So let's bring out our mint green, illustrate, intersect the focal point like this, and the next color, intersect our focal point like this as usual. The only difference is that the location of the object. I hope that's accurate. There you go. Basically, this is our intersection, and this is the projected position of the object. So we can conclude from this finding that the object is real. It's still real. It's still on the real side. The object is inverted, still inverted, and the object is now magnified. Why is it magnified? Well, it's already taller compared to the initial position. Alright, so I hope you can see the pattern here. Let's have a recount. For case 1, object is real, inverted, diminished. Case 2, real, inverted, and the same size. Case 3, it's still real, inverted. Now, this time, it's magnified. Alright, let's move to case 4. Case 4 will always be remembered on a specific condition, given that the object is on the focal point. Right, let's bring out our template. There you go. Remove our arrow there, move it to the focal point. So given that our object is on the focal point, just do this. Most probably our case 4, yeah, let's just extend it all the way there until here, and still we have to intersect our focal point. It looks really weird, but this is what we really have to know. This is what we have to bear in mind, especially during the exam. questions regarding this topic would be, it could be said that it could be really confusing. That's no excuse. Everyone's going to encounter that anyways. But in order to keep yourself from being confused, you should be, you could practice drawing these illustrations. That's why I'm teaching it to you right now, because just like what my teacher said, um, you'll be able to understand it. You'll be able to memorize if you know how to draw the illustrations, the ray diagrams. So we'll be assuming that what I'm trying to draw right now is parallel lines. So parallel lines, I'll just write it there. Parallel lines. Case 4 will always be remembered for parallel lines. So for the virtual side, we'll be extending like this. I hope that's a perfect line. There you go. And in that case, will be, as usual, the virtual side will have dashed lines. Alright. So in that case, we don't have space anymore. Let's place it here below. Object is non-existent. There is no object at all. There you go. So there is no object because the lines are parallel. So there is no intersection at all. That's what we always remember for case 4. No object projected. Now, let's move to case 5, the last case. Case 5 is all about the object located between the focal point and the mirror itself. Alright. Oops. Let's make this partial. Between the focal point and the mirror is located here. And in that case, I think it's better to just limit our mint color, our mint line here at the very mirror. You won't have to extend it anymore. Reflect, so it would be like this. And let's move to our next line, which is the red. We'll basically place this at the origin, point of origin, as if this is a plane mirror and point of origin is here. And yeah, reflect. You could at any degree you want. I don't think there's any problem with that. There's no issue with that. So let's just make it that way. Virtual, place it this way, and yeah. What's important is these two lines will intersect in the virtual. So this is what exactly happens. And don't forget dashed lines in the virtual side, the virtual realm, and the arrow. So you can conclude here that the object is now virtual. So out of all cases, it's only at case 5 that the object becomes virtual. You could make that conclusion. Apart from being virtual, the object is upright. It's upright because it is above the principal axis, just like the initial location. And apart from being upright, the object is now magnified. There you go. Conclusion for case 5, this is what we get. Those are some ugly commas. So yeah, that's it for this video. We'll be continuing our next lesson about basically convex lens, I think. I'll have to consult my manual first, my reviewers, and I'll be translating it here through YouTube videos. So let's just recall, summary. For case 1, before the center of curvature, the object is real, the object is inverted, and it's diminished. This is how we illustrate it. So for case 2, let's choose a different color for the highlighter. Let's try brown. So case 2, on the center of curvature, the object is real, it's inverted, and it's also the same size. And this is how we illustrate it. And always keep in mind, the center of curvature, the intersection looks like a Ben 10 watch. So if you're fond of Ben 10, you'll memorize this easier. And let's choose a different color, maybe light green, lime green. Case 3, between the center of curvature and the focal point, the object is real, inverted, and magnified. And this is how we illustrate it. For case 4, on the focal point, different color, orange. Basically, there's no object. Parallel lines. So let's have that. And finally, let's just choose pink. Case 5, between the focal point and the mirror, the object is virtual, upright, and magnified. And this is how we illustrate it. There is a really keen intersection here. It resembles an X, but this time it looks like this. So yeah, that's everything that we have to know for concave mirror ray diagram. Goodbye and thank you. Thank you for watching this video.